Unpaired electrons for the metals and non-metals are central to figuring out bonding. And only have a focus on the first 18 elements again. I think that's best. We're keeping this as simple as possible, and remember, we are trying to get to grips with bonding. And for this, you will specifically need to learn what an unpaired electron is. You don't need to know why it is unpaired, just follow the rules that are given. Because, in chemistry, sometimes you apply rules of advanced theories. And that's without going into the theories and just learning the basic rules. That happens quite often at a basic level. And this is one of those cases whereby for now you just apply the rule. Just remember this, when there are more than 4 electrons on the outer shell, each electron after 4 will form a pair, and then it is only the unpaired ones that form bonds. Easy to remember. So let's go through the elements one at a time, starting with the metals. I've already drawn these out, so I'll use the symbol rather than the name, as you do need to get used to the symbols. We have lithium in group 1, beryllium in group 2, sodium also in group 1, magnesium in group 2, and lastly aluminium in group 3. You see the atomic numbers already added in red. That's very handy, and it lets us know how many electrons we have in total. The number of outer electrons for these groups of metal atoms is the same as the number of unpaired electrons. Group number 1, lithium and sodium, 1 outer and an unpaired electron, or it is an unpaired electron. Group number 2, beryllium and magnesium, 2 outer unpaired electrons. Group 3, aluminium, 3 outer unpaired electrons. In each of these, the number of outer electrons and unpaired electrons is exactly the same thing, and the number of bonds that atoms of these elements can make is the same as the number of unpaired electrons. Let's use the keyword valency, because valency is the number of bonds an atom or ion can make. For these, the valency is the same as the number of outer electrons, and valency is always the same as the number of outer electrons that are unpaired. So you could say that takes care of metals. Now, non-metals. We only have 9 to think about, so here they are. Boron, group 3, carbon, group 4, nitrogen, group 5, oxygen, group 6, fluorine in group 7. And you can use the periodic table yourself to identify the other elements on the next row. What you should see here is that some of them have electrons that are in pairs on the outermost shell. We ignore the pairs and only use the unpaired electrons to decide on the number of bonds that can be made. So let's write down the number of unpaired electrons like this. Under group 3, it's 3. Under group 4, it's 4. Group 5 is 3. Group 6 is 2. And group 7 is 1. Can you see that group number doesn't always equal unpaired electrons? The number of bonds that are made goes along with the unpaired electrons, just like the metals. Look, boron, 3 unpaired outer electrons, carbon, 4 unpaired outer electrons, nitrogen, 3 unpaired outer electrons, and a pair of electrons that we ignore. Oxygen has 2 unpaired electrons and 2 pairs of electrons that we ignore. And fluorine has 1 unpaired electron and it has 3 pairs that we ignore. Same as the metals, unpaired electron number is what we call valency. So let's write the valency numbers like this. Valency 3, 4, 3, 2, 1. Remember, valency is the same as the number of outer unpaired electrons. And let's finish up with using the valency rules for writing a formula. You might recall the SVSDF rule. S for symbol, V for valency, S for swap, D for divide, and F for write the formula. Here's an example. Lithium and nitrogen are reacting. Li for lithium and N for nitrogen. Those are the symbols. Lithium, valency 1, nitrogen, valency 3. Swap the valencies. Divide, and you will notice it is already the lowest whole number ratio. Finally, the formula. But why is this the case? Here's a quick explanation. Let's turn these atoms around first. Now you should see that lithium can only form one bond. It has a valency of 1, only has one outer electron to bond with. Nitrogen has 3 outer electrons that need to make bonds. Atoms are always wanting to be stable, like noble gases. So nitrogen needs another 2 lithiums. And here they are. And both atoms are now bonded. An easier way to do this is with symbols and dots and crosses. We call this a dot and cross diagram. For this we use the symbol and show the outer electrons as dots on one atom and crosses on the other, like this. And to show how they bond, like this. And between the nitrogen and lithium are pairs of electrons represented by a dot and a cross. You may also have seen it written like this. So that is why it is Li3N. All for now.